Welcome to lecture number 6 for Introduction to Computer Science. Today we're talking about the programming layer, which is the most important lecture for computer scientists. This is where we make our bread and butter. Okay, first of all, what's a computer program? A computer program is a sequence of instructions written to perform a particular task. So, for example, if your mom asks you to make a cake, what your mom is going to do, she's going to give you a recipe. She's going to give you a list of instructions. Those lists of instructions is a sequence of instructions you perform a particular task, like making a cake. That's no different than what you'll do with a computer. You're going to get a computer a list of instructions to perform a particular task. So instead of making a cake, it may be to control a robot, or it may be to open a door, or it may be to control an airplane. Either way, what you have is a sequence of instructions to do a particular task. Now, these sequence of instructions require you to think logically to solve the problem. Without logical thinking, it's going to be hard to logically create a solution to a particular problem. And the solution that you create to the problem is called an algorithm. Now, let's look at problem solving in general. The act of finding a solution to a perplexing, distressing, vexing, or unsettling question, this is problem solving. I know there's a lot of descriptors there, but basically just kind of show you problem solving is basically just finding solutions. In the problem solving method, the first thing to do is to ask a lot of questions. Here's some questions you'd like to ask yourself. What's known? What's unknown? What are the data? What is the condition? Is it possible to satisfy the condition? Are there any special cases? So for example, if I dropped you off in the middle of the woods with a flashlight and I say, get back home, you need to ask me some questions. That's the problem. You're in the middle of the woods, you got one flashlight trying to get home. So one question may be, where's home? How far away is home? Can I call for help? Are any special circumstances I need to get home doing? All these questions you need to ask yourself before you can start the problem. Next, you need to find similar problems. Ask these questions. Have I seen this before? I don't want to reinvent the wheel. What are similar solutions? Have people been dropped in the woods before with a flashlight? How do they handle it? How do they fix it? Are there any similar problems to this? You got to ask yourself those questions. Second, you need to divide and conquer. What you need to do is you need to break down any problem to as small as pieces possible. So you break the problem into smaller pieces. Then you break the smaller piece into sub pieces, and then you create solutions for the sub pieces. So you want to get the problem down to as smallest level possible. And then once you get to the smallest level possible, you want to connect all the sub pieces together. All right, now once you have a sub piece, the first phase is to analyze and make specifications. So you want to find a problem very specifically. You don't want to be general. You want to be very specific. What are you trying to solve? Phase 2 is algorithm development. You want to create a logical sequence of steps to solve the problem. This you can write out in English or any way you want to lay out the problems. You can get sticky notes and arrange them on your board if you want to, but you want to create a sequence of steps to solve the problem. That's called the algorithm development process. After the algorithm is developed, what you want to do is you need to translate that algorithm into a programming language and then test the result. So if you wrote the algorithm on paper, maybe you write a solution in C++. Maybe you write it in Java. Maybe you write it in Python. Maybe you write it in PHP. It doesn't matter the language. It's just that you take the algorithm, you got to translate it into a language that a computer can understand. And if it doesn't work, you just repeat the process over and over again until it does work. Now, once you got all the sub-problems solved, you add them all together and you get one solution. All right, here's the problem. Cook a 3-course meal for your wife or your girlfriend. So the reason I use the word wife or girlfriend because this is for Morehouse students. Most of the Morehouse students are male. But if you're a female, maybe your problem is cooking a meal for your boyfriend or your husband. All right, so here's the problem. First step is ask some questions. Here's some questions to ask yourself. What is a 3-course meal? What does she like to eat? What does she not like to eat? How much time do I have to prepare? So these are some good questions you ask yourself just to get the problem going. Step 2, find similar problems. Ask advice from friends who've done this before. Determine what I already have in the kitchen. Call your mother for recipes or look online for recipes. You want to find similar solutions, similar problems. Step 3, divide and conquer. You want to take it, you want to break it down. So obviously you can break it down to the courses. You can make course 1 first, you can make course 2 second, and you can make course 3 third. And then in step 4, you want to put it all together and serve each course separately with short pauses in between. Okay, I know it sounds kind of simple, kind of generic, but just that 4-step process pretty much solves any problems. You just got to go through those steps. Now let's be a little bit more specific. Let's look at a sub-problem with cooking course 1. Let's look at an appetizer. What are the specifications? Let's specify something very specific we want to do. Let's prepare an appetizer or spinach dip. That's what we're going to do in phase 1. We just specified the problem. Phase 2, let's outline a logical sequence of steps to solve this problem. So I looked up on Google and I found a list of 5 instructions to make spinach dip. Step 1, medium bowl, mix together 1 cup of mayonnaise, 16 ounces of flour, sour cream, 1.8 ounces of dry leaf soup mix, 4 ounces of water chestnuts, and 10 ounces of chopped spinach. Step 2, chill in the refrigerator for 6 hours and overnight. Step 3, remove top and interior of sourdough bread. Step 4, fill dip mixture. Step 5, tear, remove bread chunks into pieces for dipping. All right, simple instructions. So now we got to take this algorithm, we got to convert it into a computer program. All right, let's do the conversion now. Step 1, we need to input. Input basically means this is what the user is going to put in. So the user is going to put in 1 cup of mayonnaise, and it's going to be input into the variable M. Next instruction, input 16 ounces of sour cream, saved in the variable S. Input 1.8 ounces of dry leaf soup mix, saved in the variable D. You're getting the hang of this input, right? Input 4 ounces of water chestnuts, saved in the variable W. Now, keep in mind, this is just an example, so this actually wouldn't work in your computer. Next one, input 10 ounces of chopped spinach, saved into variable X. Then you take a new variable bowl, and it's equal to M plus S plus D plus W plus X, all saved in the variable bowl. Next, you have a statement here. It says, while time is less than 6 hours, keep bowl in the refrigerator. This N goes with this while. Also, look at these semicolons here I keep adding. These semicolons basically means stop the instruction. So when the computer sees that, it knows that that's the end of that particular instruction. Next variable is SB. The function is remove. Top of sourdough bread. And you stored it into SB. And that's all stored into SB. Next, remove interior sourdough bread. And that's stored into SB again. So you take SB, that's now just the sourdough bread with a top on it, and then you remove the interior. So you're using the exact same variable, and you're just storing it back in itself. Next function is a fill function. So you want to fill the sourdough bread with the bowl mixture, which comes from right here. Next, you want to tear the sourdough bread, tear the top of the sourdough bread and store that into BX. And then your output command is you want to output MX and BX. Now MX is just the bowl of sour cream of spinach dip mix, and BX is the actual bread chunks.